In nature, you won't find many 90-degree angles, and there's a reason for that. Things are more stable, and it's more economical in terms of material. When you start looking at like 110 or 120 angles in nature, you'll find that over and over again, for example, in the way that plants grow, but also in microscopic structures. And so the deal here is to explore the sophistication with which nature is able to construct at the micro scale and at the large scale. And so we're looking at other geometries besides the 90-degree angle, right? And that can lead to more environmentally efficient structures which can use less material, or can be optimized in terms of like building skins for orienting the sun's position as the daylight comes into the building and things like that. So what's unusual about this is that the angle of approach of the tool as it's coming in does not have to be straight in. Because I have this wrist on the machine, I can change the angle of approach, which means that the shape that it's cutting on the front of the surface can be different from the shape that results on the back of the surface. So you're able to get much more complex geometries cut that way. Whereas usually, like the 3-axis machine you'll see at the architecture school, it can only cut straight down, so it can only move back and forth like this. So you can get it to do things like this 3-axis milling here, but for example, you can't get what are called these swarf patterns, which are much more complex geometrical patterns.
So these are the ones that were generated in what's called rhinoceros grasshopper software, and so there's multiple iterations in one project. So I think these are like 1 student, these are 1 student, those are 1 student. So it's just a quick and fast way to produce iterations of an idea. Actually, what's being printed is here. They're pretty tiny. So what I do usually is just kind of find the all of the edges. Once I cure them, I'll be able to like glue them together.